If we're stardust, and if we're golden, we're now just a little bit closer to understanding what that means. This afternoon, NASA made an announcement. Astronomers, using data from the Fermi Gamma Ray Space Telescope, have developed a new way to understand the most ancient light of the universe. And all the light. Or, as NASA sums it up, appropriately pragmatically and appropriately poetically, the total amount of light from all of the stars that have ever shone. That light, photons from primordial stars, formed some 400 million years after the Big Bang. Thank you for trying verbose. This recording will go away once the product has been purchased. Is still extant in the universe. It is more commonly known as extragalactic background light, or EBL, which is an accumulation of all the radiation in the universe, but which is also, more awesomely, all the starlight and all the goldenness that universe will ever know. It is also, less awesomely, a kind of cosmic fog. One of Fermi's main missions has been to understand the EBL more clearly, to use its clues to create a skeletal guide to the stars of the early universe. And today, mission accomplished. Marco Agello, a postdoctoral. Thank you for trying verbose. This recording will go away once the product has been purchased. Researcher at the Quilly Institute for Particle Astrophysics and Cosmology at Stanford and the Space Sciences Laboratory at Berkeley, has led the team that turned to gamma rays, the most energetic form of light we know of, to understand those ancient stars. The optical and ultraviolet light from stars continues to travel throughout the universe even after the stars cease to shine, and this creates a fossil radiation field we can explore using gamma rays from distant sources, Agello said. Those distant sources are blazars, compact quasars, or galactic nuclei, that boast. Thank you for trying verbose. This recording will go away once the product has been purchased. More than 1 billion times the energy of visible light. Agello and his team, for this project, studied 150 of them. Blazars are powered by massive black holes that emit jets of energy. And those jets include gamma rays. Gamma rays were the keys to the EBL project. When those rays collide with ancient photons, they're converted into electrons and their antimatter positrons. That collision effectively dims their light, meaning that gamma rays, then they finally hit our Fermi telescope, have an energy that belies their path through the universe. Using measures of that energy, Agello and his colleagues. Thank you for trying verbose. This recording will go away once the product has been purchased. We're able to determine the amount of photons between Earth and the blazars. In other words, light, measured. So, using this method, what's the scientists' best guess for the makeup of the universe's ancient, photonic fog? The average stellar density in the cosmos, they estimate, is about 1.4 stars per 100 billion cubic light years. Which means that the average distance between stars in the universe is about 4,150 light years. Yes. Here, for more on this, is an animation of the general method the team used to. Thank you for trying verbose. This recording will go away once the product has been purchased. Track gamma rays through space and time. It starts with the rays emission in the jet of a blazar and ends with their arrival at the Fermi telescope. The ultraviolet and optical photons are in blue, and they increase as more and more stars are born in the universe. About 30 seconds into the video, one of the gamma rays pink encounters a photon of starlight, and the ray transforms into an electron and a positron. The blue and red circles. The gamma rays then arrive at Fermi, where they interact with the tungsten plates embedded in the telescope. Thank you for trying verbose. This recording will go away once the product has been purchased. All that, they provide astronomers with the data they need to trace the gamma rays to their sources. So there it is, starlight, in numbers. The Agello team's measurement, and its process for stellar deduction, was published today in the paper in the journal Science. That team, and many more scientists, will be using those findings to make further determinations about the makeup of the early universe, to better understand, all in all, who we are and what we're made of. Someone should probably tell Joni Mitchell,